This video in the PM1 course covers sketching quadratic functions. Now, y equals x squared minus 5x plus 6 is a quadratic function. Note that if I just write x squared minus 5x plus 6, this is a quadratic expression. And if I write x squared minus 5x plus 6 equals 0, this is a quadratic equation. But if we have y equals x squared minus 5x plus 6, we have a quadratic function. And functions can be sketched on coordinate axes. Now, the general form of a quadratic function is y equals ax squared plus bx plus c, where a doesn't equal 0. To be a quadratic, you must have an x squared term. You may or may not have an x term, so b could be 0. You may or may not have a number term, so b could be 0. But you must have an x squared term, so a cannot be 0. Now, what does this look like? You should know the general shape of a quadratic is like this, a parabola, or it could be like this, upside down. Which it is will depend on a, b and c, and where it is will depend on a, b and c. In fact, let's have a look at quadratics where we can vary a, b and c. Now, here is a quadratic function and it's sketched in this computer program. And this one is y equals x squared minus 5x plus 3. And I can vary the values a, b and c, the coefficients of x squared, x, and the number. As you can see, a is 1, I've got x squared, b is minus 5 here, and c is 3. Now if I vary a, you see, here we've turned it upside down. And that occurs when a is negative. So when a is negative, it's sort of upside down. When a is positive, it's this U shape. So the value of the coefficient of x squared, the a, tells you whether it's U shape with a minimum point, the point where it comes to the lowest value of y here, or whether it's like an N shaped or an upside down U, like that, where it has a maximum point, which is there, the maximum possible value of y. The value of c, if I change that, well, that is the value where it intercepts the y-axis. So you can see here, c is 6, and this is the point it crosses the y-axis, where at 6, y equals 6, and that is of course the point where x equals 0. If x equals 0, the x squared and the x terms are both 0, and y equals 6. As I vary c, you can see there we have c equals minus 3, and here we have down here it crosses or intercepts the y-axis at minus 3. Varying b just changes the position of the quadratic. In fact, a quadratic relative to the axes could be over here, and that's when it's in the first quadrant, in this quarter here, or it could be over here in the second quadrant, that is the minimum point in the second quadrant, or it could be over here, the minimum point in the third quadrant, or it could be over here, the minimum point in the fourth quadrant, or it could have a maximum point. If I change A, here you have the maximum point, that's in the second quadrant, or it could be in the first quadrant. We can move it down third or fourth. Now when we sketch a quadratic, we need to show where it crosses the coordinate axes. So for instance this point here, well that's just the value of C, the number term, so that would be just 3. Where it crosses the x-axis, well where it crosses the x-axis is where y equals 0. So y equals 0 would mean solving the quadratic equation, in this case minus 2x squared plus 4x plus 3 equals 0. And we also should be able to say where the turning point, the minimum or maximum point, where is this point here, which quadrant is it in. So in addition to that, you need to have the correct shape, either this upside down U or this U shape like that. So we need these three things: the shape, which is either that or that, the points where it crosses the axes, which in this case is only the y-axis at 7, and the position of the minimum or maximum point. Well, not necessarily the position, the quadrant that it's in. Now, if it crosses the x-axis, like this one here, then it's quite easy to see which quadrant the minimum point is in. We can see that if if it's the two values are both positive like this, clearly it's going to be the minimum will be in this fourth quadrant down here. Both negative, and the minimum's in the third quadrant. One negative and one positive, like this. There's a negative, there's the positive. Well, if the negative value is further away from the origin than the positive value, then we've clearly got the minimum point down here in the second quadrant. On the other hand, like in this case, the positive value is further away than the negative value, then we're in the fourth quadrant like that. Of course, it's possible that it doesn't cross the x-axis at all. In other words, there's no solutions to the equation, in this case 2x squared minus 3x plus 2 equals 0, in which case we'll have to do something else to try and find which quadrant the minimum point is in. Is it there? Is it there in this case? Or if it's a maximum, is it there? Oops. Is it there? Or is it there? And we'll be showing, I'll show you how to do that. One other possibility is this. It's possible that the curve looks like this, where it touches the x-axis and it crosses the x-axis once. There's only it sits on the x-axis like that, and that is where x squared plus 2x plus 1, the quadratic in this case, x squared plus 2x plus 1 is a perfect square, x plus 1 squared. So I'll be covering all of those cases. So let's consider this quadratic here, y equals x squared minus 5x plus 6. First of all, we note the shape. the coefficient of x squared is 1, so the shape is like that. Then we consider, where does the curve cross the coordinate axes? Well, it crosses the y-axis when x is 0, and that's the number term here, 6. So the intercept with the axes, the y-axis is 0, 6. And for the x-axis, we want to find the values for which y equals 0. So x squared minus 5x plus 6 equals 0. You could note from the previous videos that a quadratic like this factorizes, or may factorize. This one does factorize. X minus 2x plus 3 minus 3 equals 0. And so x equals 2 or x equals 3, and the intercepts with the axes are 2, 0 and 3, 0. So to sketch this curve, we know that it crosses the y-axis at 6, the x-axis at 2 and 3, and it has a U shape. Now that means that the curve will go below the x-axis and look like this. It will cross at 6, it will cross at 2 and 3. Now, to sketch this nicely, if you put the points in first, and which are only rough positions on the axes, you may struggle to get a nice looking curve going through those points. The best thing to do is to recognize that it must go through a value in the positive y-axis and 2 values on the positive x-axis. Sketch a curve with those characteristics like this, so you can get a nice shape without trying to draw the sketch curve to particular points, and then indicate the values where it crosses the axes 6, 2 and 3. And that's all you need to do. We should label our axes y and x as well. Supposing we have a negative x squared term, so a in this case is minus 1. Well, we do the same thing again, but with an added step. Factorize the quadratic by taking out the factor of minus 1. So make that x squared plus 5x minus 6. Now that's a similar equation to the one we had before. But it has quite different factors. We see we have plus 5x minus 6 instead of minus 5x plus 6. But the factors of this equation, of this expression, are x plus 6 and x minus 1. You see we'll have x squared minus x plus 6x to give the plus 5x, and then minus 6 times from 6 times minus 1. So, to sketch the curve, the shape, first of all, what is negative x squared? So it looks like that. The intercepts, well, we've got plus 6 when x is 0, so 0, 6 again, and then we can see where x equals minus 6 or x equals 1, y equals 0, so we also have minus 6, 0 and 1, 0 as the intercepts with the x-axis. So in this case we again have a intercept of the y-axis up here at 6, but we have intercepts of the x-axis down there, minus 6 and plus 1. Intercept either side of the y-axis, but the minus 6 is further away, and so we must have a minimum point down here somewhere. So the thing to do then is to ignore those specific points for the moment and sketch the curve with those characteristics. We want to be down there and up there. So that was incorrect. As the curve is the N-shaped, that has a maximum, in fact, as it goes through this point here on the y-axis, there on the x-axis, and there on the x-axis, in order to do that, the curve must look like that. As the minus 6 is further away than 1 from the y-axis, then the maximum is in the second quadrant. Of course, it must be above this point here, 6, because this is the maximum value, which therefore must be more than the 6. Otherwise it wouldn't be a maximum, and it wouldn't be able to go through that point. So as before, knowing those characteristics, it's better to sketch it freehand without putting in the points first. We know we've got to come up there and down there, and then we put in minus 6, 1 and 6. Label the axes like that. Now, what if your quadratic function or your quadratic expression doesn't factorize? We consider this example, y equals x squared plus 6x plus 10. This doesn't factorize. If we look at the discriminant, discriminant b squared minus 4ac, which we would have learnt about in previous videos, that is 36 b squared minus 4 times 1 times 10, which is 36 minus 40, which is minus 4. And as you will have learnt, that when the discriminant is negative, then the quadratic equation, if x squared plus 6x plus 10 equals 0, has no solutions. So in this case, this function won't cross the x-axis. There won't be any intercepts. So to sketch this, we first start with the same process. What shape is it? We see the coefficient of x squared is positive, so it's like that. The intercept with the y axis is where x equals 0. We still have that, so we have 0, 10, but we don't have any intercepts with the x-axis. So we want to sketch the graph, sketch the function. We know that it goes through a point up here, 10, and we know it doesn't cross the x-axis. We know that it's a U shape. It has a minimum point, but we don't know where that minimum is. We don't know whether it looks like this or it looks like this. So that's what we shall find out. To find that minimum, there is 2 ways of doing it. One way we'll meet later on when you do the differentiation topic, but the other way you can do already, and that is by completing the square on the quadratic expression. Now if you remember, we have y equals x squared plus 6x plus 10. To complete the square, we must consider the coefficient of the x, 6x, halve it, 3, and square that, 9. So we add 9, but if we add 9, we've got to take away 9, so we haven't added anything, and then we have plus 10. And the reason for doing that, of course, is that that bit there becomes a perfect square. Well, what one would you like to do? Y equals x 2x squared plus b squared minus 4ac, so 6x plus 3. You've already got a minus there. That's right. Oh, I've got 8. That's 9. 10. Doesn't touch 9. Three over 2, 9 over 4, minus 9 over 4, 5, and x plus 3 over 2 squared, four nines are 4 5s are 20, minus 29, 4. 3/2 minus 29/4. No, it's down there. No. Minus 10. So that. Minus 29/2. Which is minus 15. So in fact that is down there. So